Hello there and welcome to Lower 6th Further Maths A-Level January Mock Exam Revision Sheet 2. Here we're working on question 5. So we have a system of equations, a 3x3 system of equations, and show that the system of equations is not consistent to start with. So what we should have when we find the determinant of the matrix that forms this system of equations here is that this will equal 0. Now to form the system of equations matrix, what we're going to need is a 3x3 matrix that will times together with x, y, z to make the 12, 4, 20 matrix at the end. So what we need is to realise that as we go along the three values here, here and here, we're going to be timesing these three by x, y and z as we go along, and that will make our equation. So what we need here is a 1 in this space here to times by the x, a minus 2 in this space here to times by the y as we go down and along, and as we continue to go along and down, we need a 1 in the next space here to make the z part of the equation here. The next spot here is going to be working one down, 3, and then that would be 3 times x. Working along, we need a 1 to times by the y, and a minus 5 to times by the z. And the bottom here is going to be 5 to times by the x, minus 3 to times by the times by the 3y, and another minus 3 here to times by the z to make minus 3z. So our matrix here is 1, minus 2, 1, 3, 1, minus 5, and 5, minus 3, minus 3. So, to work out the determinant of this matrix here, we need to do 1 times by, so we now cross out the row and the column for the 1, and then find the determinant of the remaining 2 by 2 matrix here. So it's going to be minus 3, take away, minus 5 times minus 3 is 15, so we take away 15 here. So this is going to give us minus 18. For the next one, now the next one's a little bit more tricky. We need to now incorporate the matrix of matrix of cofactors into our determinant. So originally the first one was a plus, so we used plus 1. The next one's a minus, so we use minus of minus 2. That makes it effectively a plus 2 for the next bit. Cross out the row and the column, we get minus 9. Take away 5 times minus 5, that's minus 25. Double negative will appear there. So we're going to get 25 take away 9 is 16. 2 lots of 16 is 42. No, 2 lots of 16 is 32. And carrying across the row here, we need plus 1. Plus because we have a 1 here. Plus with plus here, and we have a 1 here. Times by, cross out the row, cross out the column, minus 9, take away 5. So minus 9 take away 5 is 14. So minus 18, add 32, you get 14, take away 14, and you get a 0. Okay, good. So hence, not consistent, or not a unique solution, rather. Consistent refers to whether there are any points at which the three planes overlap each other and have a connection at all three planes. Identify the geometric configuration and of the planes defined by the system of equations. So what we're going to do now is we're going to attempt to solve these as simultaneous equations and then see what we end up with. Okay, so what I'm going to do first is trying to eliminate one of the letters. I'll try and eliminate the x here. I'm going to do equation, I'm going to call these equations 1, equations 2, and equations 3. I'm going to do equation 2, take away 3 lots of equation number 1. So I have to times equation 1 by 3, and then I'll take it away from equation 2. So 3x take away 3x, so that will give me 0. y take away minus 6y, that will get a double negative there, so it will be y add 6y will give me 7y. And then minus 5z take away 3z, that will give me minus 8z. And 4 take away 36 will give me minus 32. Okay, so the next way, I think I'll link equations 1 and 3 together. So I'll use equation 3, but to eliminate the x this time, I'll times the first equation by 5. Okay, so 5x take away 5x, that's 0. Minus 3y take away minus 10y, that would be a double negative. So minus 3y add 10y will give me 7y. Minus 3y add 5y, no, take away 5z. So minus 3z take away 5z will give me minus 8z. And 20 take away 60, so 20 take away 60 is minus 40. Okay, so what we're going to get here are what we've done here. So the method that we've used is to eliminate the x variable in two different ways. So that's how you come to a conclusion as to what geometric configuration you have on your hands with these system of equations here. So we've eliminated the x variable and we've got these two equations here now. So we can definitely tell that they are parallel, but not equal, because the number on the end doesn't match up with each other. So we have two equations here that are parallel. And hence from here, what I can infer is that the system of equations are not going to intersect at any point, otherwise these two equations here would be equal. System of equations, what in fact they're going to do is they are going to form a triangular prism. So they're going to continue being parallel to each other. So we have one, they're going along like that. The second plane will be going along like that. And then the third plane will be going along like this. And when you combine them, you're going to get a triangular prism where they're all going to be parallel to each other, but not all three of them are going to intersect at any one point. Okay, 6 marks for that.